Ladies and gentlemen, please welcome Ari Gesher.
Good afternoon, everyone. It's good to be back. It's been so long since I've been here, like a few hours. But today we're going to talk about, or this afternoon we'll talk about something a little bit different, right? And that is how to get product feedback when your product is on a website. And I don't claim in any way to be an expert, and this is not going to be sort of an enumeration of all the different ways that you can get product feedback if you're not pulling things like out of your own web servers. But really it's more of kind of a story about how we approach this problem, and hopefully you can extract some value from the anecdotes that we experience here at Palantir. So as we know, this is the reason for the season. There's that build, measure, learn cycle, and you can't learn if you can't measure, and you'll build the wrong thing if you're not actually learning, right? So how you measure becomes really important. If you're running a website, which is the way that a lot of scalable businesses are built today, it's actually really easy to do, right? You can just smack software sensors all over the whole thing, pull in more data than you can possibly imagine. In fact, some of my former colleagues left to go work at a company called Hunch, which is sort of taking instrumentation of these websites to a whole new level, and turning, like literally pulling in massive streams of data about everything using JavaScript. So if you have a website, it's super easy to measure. But the question is, what if you can't get direct access? What if you can't be inside the computer where your customers are interacting with your product? So this is a problem that we have in spades at Palantir, where I work. We're a traditional software company, right? We write software and then we ship it to customers, and they run it on their computers, right? So it's like we're kind of not really involved at all. So let me give you just a quick overview of kind of what we do to give you a sense of the problem that we face. So Palantir kind of defies that elevator pitch. If we put it together into a sentence, it sounds something like this: build products that make people better at their most important work, right? Another way to put this is that we build data analysis systems that can take in data from many, many different data sources, all which describe the same real-world problem, compose that data together into a model that's understandable by a human who knows a lot about that problem out in the real world that data represents, but doesn't know a lot about data systems, right? And so when you start with this human factored problem, we call it data fusion. When you start with it from this human perspective, really what you're doing is you're kind of doing a projection, right? When you think about the way that databases work, data systems work, they compose their primitives. The way in which they represent data has to do with data storage. Has to do with the way the computer views, manipulates, queries data, not the way that people think about data. And so we do this projection into a completely different conceptual space, where what the user sees are actually sort of real-world objects that relate to what's going on in their mind. So if you're studying infectious disease, you see people checking into hospitals, hospital reports. If it's foodborne illness, maybe shipments of food moving through a food network. Anything that you can, as like a health department, get your hands on and integrate together into a coherent picture. You can conceptually think about putting all that data together in a database and giving someone a SQL prompt, saying, "Here's all the data you need," and they say, "Wow, I studied epidemiology. I don't really know SQL. I'm not sure what to do with this," right? And so you need a way to give it to them in a way that they can understand. Under the covers, it's kind of a complicated beast, right? This is a single architecture, like an example architecture of what a single Palantir cluster might look like with all the different various pieces connected to each other. It's kind of a complicated thing, right? Just from the back-end perspective. And this doesn't even touch on the user interface. If you look up in the sort of near the top, you see those three screens. Those are the icons in this diagram that represent the users actually running the client part of the program on their machine to actually access and view the data, which is sort of a whole other domain of engineering. So there's not going to be a test on that. This is sort of a quick screenshot. If you go to our website, there's lots of examples if you're interested in learning more about this, but that's not really what the talk is about, but it serves as really useful background. We've gone through sort of three distinct phases in our engineering. Early on, the idea for what became the Palantir Data Fusion platforms actually came out of PayPal and work that was done there to build anti-fraud systems, right? So the idea there was if you can take humans and computers and get them to work in concert, they can actually work very effectively against data problems that you can't solve with automation. And this is how PayPal ended up winning the payment wars. And what came out of that was a recognition that they had done something really neat with technology and they should build a company out of it. That's how Palantir was born. Peter Thiel was our founder. He realized that that was the one big piece of technology that was built at PayPal that could be applied to many different problems out in the world. So in the early days, we just had this idea. We didn't have any technology that we took from PayPal. It was just like, hey, humans and computers should work together. The computer should help the humans as much as possible. The humans should see the data in a way they can understand it. And so what followed was actually, this period of inventing the future. What does this look like, especially if you're going to build it in a generalized way? And what that invent the future period looks like is 2 years of prototyping. And that's 2 years of prototyping without a customer, without any way to sort of get feedback in a traditional sense, right? Is that worrisome?
Danger, Will Robinson. Danger.
Yeah.
Danger, Will Robinson.
It's definitely worrisome. This is the kind of situation that you can get in, you can waste a lot of time and money and build completely the wrong thing, right? You have to get feedback in some way. And so what we ended up doing, this is Stephen Cohen, one of our founders and one of the early coders on our prototypes. Between sleeping under his desk, drinking Red Bull, and furiously coding up things that would later be discarded once we started doing what I would call serious engineering, he would every 2 weeks get on an airplane and fly out to Washington. So we had identified that the first market that we really wanted to work in was the national security space. And so he would actually go out to these meetings with people where sometimes they wouldn't tell them their last name or even their first name or who they worked for, but the meeting had been set up and he could just sit down and demo the prototype and say, would this be useful for your work? And in the first set of meetings, the answer was invariably, that looks useless. I have no idea what we'd use that for. And he'd say, well, how do you do your work? And they'd say, well, here's what we can tell you about it. And he'd say, well, that's interesting. And they'd go back and they'd furiously code for 2 more weeks and he'd fly back out and do another demo and show them everything. And they'd say, well, 95% of that is crap, but that last 5%, that could be useful. And so over this period of iteration, we got to build up exactly the shape of the system that we needed to build that we could take to market, right? And this actually continued, right? So during the zero customer era, as we can call it, just get feedback. Doesn't matter how, right? Even if you can't go with any of those sort of existing channels and strategies like putting a prototype in front of a customer, go find some people who might be your customer. Whatever you can do to get feedback, you need something to put constraints on what it is that you're building. Now, some people might say we got lucky. I'd say that. Some people might say we were just good, that in 2 years we were able to synthesize this feedback into something that was useful and we could take to market. This strategy continued actually longer than 2 years. This is Shyam Sankar, who took over business development right around the time I joined in 2006. This was sort of 2 years into prototyping. We still didn't have any customers, but BD then became the roadshow that would go out to talk to all the different potential customers, see if they could get demo data sets and try things out and see what would work. And that really is what got us to the place where we shipped, right? And once we were able to ship and get some paying customers actually using the software, everything changes, right? At that point, you can get real feedback. Now you got to figure out what's the right way to get it. For us, this era was marked by sort of two ways to get this information, right? On the one hand, we had forward deployed engineers. So the way that we actually, these systems are actually not so simple to set up. It's a product, it's sort of a set piece of software, but connecting it up to data and making it useful for a team is kind of difficult. So we usually ship people along with the software to actually set it up in the first place. So our engineers go into the field of the software, help with the integration, set it up. And in that sense, they actually act as sensors, right? They can tell us how it's working, how it's not working, how the users are responding to it. So that's forward deployed engineering, and that comes actually in 2 different phases. The first was actually the technical setup phase, which could give us feedback on how the product's working in terms of how fast you can integrate it, how easily it is to get data into it. And then the second phase is what we call the embedded analyst phase. And there we have people that are doing workflow design and user training to make them more useful in using the software. And there you're actually getting sort of real end user feedback. I mean, you can think about when you have a system that's this complex, you actually have 2 sets of users. Like one is the systems administrators and like the IT people have to run a system like this. And the other are the users that are sort of sitting there and clicking on it all day and actually doing their work, right? And you need feedback from both of them. And so to enable this, what we did is we set up a support team, right? And a good way to think about the support team is actually they're the feedback team. They were a team of engineers who actually knew how to use the product very, very well, and they'd sit and answer email requests and phone requests from our people, right? The people that are actually calling in were not the customers themselves. It was our forward deployed engineers who were in the field. They're like, hey, I'm setting up this piece, it doesn't work. What am I supposed to do, right? And they're on a tight deadline. They're trying to get something to work. They just want an answer as fast as possible. And by setting up the support team, the job of the support team was not only to figure out the answer and get it to the people in the field, but document that it had happened, file any product bugs that were necessary. And so they ended up as sort of this nexus of communication to pull in all that feedback from the field and codify it in some way that was actually useful, right? And this worked actually quite well. So if we can sum up sort of that 1.0 era strategy, we put our people in the field to get as much data as possible, to get very rich data. Build infrastructure, the support team in this case, to actually carefully capture their feedback and bring it together in a useful and usable way. And then the last piece was that we actually took the forward deployed engineers and we incorporated them into product planning, right? So they became part of the product management process. Because it's one thing when your hair's on fire and you're like, this thing isn't working, or I'm having trouble integrating this, to call up and ask for help. But there's a bigger intuition, a bigger gestalt around how the product is being used that you're building up while you're in the field. And so what we do is put these people on specific feature teams, and they act as the user advocate, as the customer advocate, to say, well, I think the users are going to use it this way, or I think the best way to do it is this, based on my experience in the field. And then they act as a resource for the people who are building it to go back and say, well, what about this? Like, should I design it this way or that way? What do you think it should go? And it gives them a way to tap into that wisdom that's been established outside the office in a formal way. So this is what catastrophic success looks like in that case. So these are sort of metrics coming off our internal. This is just the support queue, right? So you're looking at something like 17,000 bugs filed, 2,100 improvements, 2,100 instances of incorrect functionality, which is a little different from the bug, another 1,700 things that need to be investigated, and a bunch of different defects and enhancements. So we're talking over like 20,000 issues, 22,000 or so issues filed in the field by people saying, hey, something's not right here, or hey, something needs to be fixed. You can react to this tactically, and the support team does, but like suddenly there's a need to understand how to understand this information strategically. And so that sort of brings us to the third phase, which is the product navigators. So we created a whole new class of folks who are involved in the product management process. So we do things a little bit differently than other places. We don't have product managers per se. And in fact, up until recently, we didn't have product designers, and that's a whole other story. Now we have lots of product designers, and they're fantastic. But product management is something that we've done as this kind of distributed task across the engineering team. So it's not that we aren't doing product management, but there hasn't been this sort of locus of power, which is the product managers who completely own the project. Instead, what we were doing was managing a very large problem space, cutting it up into a set of sort of understandable problems, and then giving those problems to engineers to design solutions around. And that worked really well, and it got us a lot of ownership and autonomy. So if you give an engineer a problem to solve, they'll often really, really own that solution in a way that they won't when they're just kind of told to do something. I'm not necessarily advocating that approach as like product management is bad or anything like that, but that's kind of the way that it worked for us for a long time. And then we realized that informational piece that the navigators bring to bear was missing, and so we had to create the product navigators. And the idea is that their job is to be this sort of nexus of synthesis. Their job is to digest all of this information and go out and find more information if we need it, so that we have an understanding of how our product is fitting with our market and what opportunities we have, what opportunities we're missing, right? So they do a number of different things. I like to split it up into sort of duties, the things that they do regularly, and then responsibilities, the things that they're supposed to sort of synthesize out of thin air, right? So their duties are to collate, aggregate, and grok this field data, right? Put it together into some sort of understandable form. What is this data teaching us? How do we turn it into the information, wisdom, and knowledge that we need to make decisions around it, right? They also meet with all the customer teams quarterly, right? So like our forward deployed folks are actually, like I said, they're building up this intuition. They're building up this really gestalt understanding of how a customer or a class of customers uses our software, or the problems with deploying it in the field. And they don't really have a good channel for reporting that outside of their normal day-to-day work, when usually their hair is on fire just like everyone else's. And so they're like, well, I don't have time to write that down. So the quarterly meeting with the navigators is a time for everyone to sort of take a deep breath and say, okay, what haven't we recorded, right? What are we missing here? What do you want to tell us about the product that you haven't had a chance to tell anyone about, right? And so that can be very, very useful. And they also go and do field user research, right? So they go out in the field and they sit with the customers and see how people are using the product, but it's also at a higher level. So it's both at this sort of low-level user research, looking over a user's shoulder, watching them do things, but it's also at a higher level, which is they go and they ask the question. This is what happens when you're led by a philosopher, right? They ask the question, why? Why does this organization exist? What are they trying to solve, right? What is the central problem that they are concerned with in the world, and how can our software help them with this, right? To really understand, is there like a whole missing piece of functionality, a completely different approach that we might take to solve these things? And then the side benefit is that if you go out and you do user research, it makes the users feel like you're listening to them, even if you're not, right? So it makes the customer really happy, and a lot of times you actually do get really usable feedback from them, but sometimes you can get that feedback and it's okay to ignore it, and the customer will still be really happy that you're listening. On the responsibility side, this is where they kind of really put it all together. The first thing they do is they look for cross-vertical product opportunities. Most of, like the way that we carve up our business development space, the people that are sort of out in the world, is sort of by vertical or by market. Like we have like state and local government, we have commercial, we have cyber. Like there's sort of different ways to slice it. And what happens is the people that end up in those different buckets have different. They kind of have blinders on their problem. But if you see like, hey, the people in cyber and the people doing research pipeline stuff for pharmaceutical companies, they're actually doing an isomorphic workflow, but with slightly different data. And there's a missing opportunity across all of this. Maybe we need to build a new product, maybe we need to build a new feature. And so the navigators are the ones that have that sort of 10,000-foot view of everything that's going on, and their job is to spot those opportunities where they exist. They also look for specific use case optimization. So going from that 10,000-foot view all the way down into the weeds, they say, hey, there's actually something really special about cyber, right? Like, when you have computers recording data about other computers, you get these massive issues of scale, and cyber deals with scale that no one else deals with. And so we need to think about how to build better user interface to deal with data at scale, for example. And then they also are sort of the ones who now act as that canonical user advocate. Their job is to make sure that the product roadmap really reflects what the user needs are. And the product roadmap is sort of its own topic unto itself. I find it kind of amusing, right? It's a mix of the existing roadmap, whatever ongoing large technology projects we have. Sometimes we have things that like take 2 years to build, like a brand new backend database. A bunch of cat herding, right? The engineers are going to work on the stuff that they're excited about, so you have to either get them excited about it or give them the thing to work on that they're actually excited about. And then the Navigator synthesized optimization priorities, which is a bit of a mouthful, but the idea being like what they're seeing that we're missing. Like what is the right way to spend those resources? Like if we build this feature, it's going to make 10 customers very happy, as opposed to this feature, which might be a little bit easier to build, but it's only going to make one customer a little bit happy, right? And finally, the sort of the new business aspirational priority. So the things that sort of that blue sky, that the navigators aren't involved in that piece so much as like, okay, what does the next generation of data analysis platforms look like? Let's go and build that. And some of that comes out of the data that they've culled, if there's a very specific opportunity that we're going for, and some of it is just kind of blue sky engineering. So that's the navigators, and that's kind of where we are today. That's actually how we collect feedback. A lot of their data, though, comes from instrumentation that we've put into the software, right? And we can't get that in an online manner. So there's a little vignette here I want to go through about how you actually get the data, how you get the data out when you're facing some obstacles in doing so, right? So the easiest way to do it is like just ship a dump file. So maybe it's running on your computers. Send me a copy of the database. It's got all the state about the software. That'll work great, right? It would work great theoretically if you could do that, but
Danger, Will Robinson. Danger.
there's a lot of problems with this approach, right? First, there's the really simple ones, right? Which is like maybe the dump file's too big, right? That one's kind of a simple, practical one that you might be able to get past. But the ones that are actually really much more germane is what about customer data, right? Do you actually want to be responsible for holding customer data? In our case, in general, we'd say no. We actually want the customers to hold their own data. We want to give them software. And now, because we're not this kind of cloud company, we're not collecting data. We want to deliver capability to data, and we don't want to incur any of the liability, any of that around holding data. It makes our business very, very simple. So If you're already holding customer data, then it kind of doesn't matter, but it is a sea change, and you have to think about what the responsibilities are around holding data that actually belongs to your customers and how you're going to handle that, who can see it, what the policies are around it. You can take it one step further, though. What about the customer's data handling policies themselves? Maybe you're okay, you've set up all the frameworks that you need to handle customer data, but the customer says, my data cannot leave my premises. Those are the rules. I don't even care how well set up you are to handle data. My data does not leave my network no matter what. If you want to come in and maybe see how the software is running, we can figure that out. But this data never leaves this network, right? So what do you do then? And so what we did is we got old school. Like, this is actually the situation that we ran into. This is Grandmaster Flash and the Furious Five. They're a very early hip-hop group. You can see they're on Sugar Hill Records. The Sugar Hill Gang is considered to be the original, the original rap group. But the technology that we're talking about is actually from the 80s. This one's a little bit older, but is the fax machine. So it turns out that when you're in a situation, when you have customers that are working on disconnected networks with classification policies about their data, if you have people with the proper clearances, maybe they can go in there, but you can't get any data out. You definitely can't get any data out in any kind of electronic form whatsoever, right? Because there's just no way to bring things in or out. That's just not allowed. But you can bring paper in and out. You can actually sometimes get 2 pages faxed. And in fact, I, as an engineer, have gotten a big, long Java stack trace that covered 2 pages of paper and was told there was a bug. Here's what you get. Make sure this doesn't happen again. And it was enough to fix it, but it was kind of like, well, that's an interesting stack trace. That's not supposed to happen. So what we decided is, rather than fight against this, let's figure out a system that we can actually work with this. So I know this is the way that most people feel about fax machines. It's the way I often feel about fax machines, but we thought really hard about what we could do to sort of make the bother get out of the way. And so it goes like this. You print out data in an OCR-optimized font, right, on paper. The paper is carried out potentially or actually faxed out of the facility, and it comes into our offices, where we then scan it and run it through OCR. And if you carefully put the data on the paper properly, the fact that it goes through this paper bridge is actually no big deal. So to look at what comes out of these sort of metrics reports, it's something that looks kind of like this, right? This is I pulled this from a PDF. This one was never faxed. And I removed the code name for the deployment. But basically, this is from one of our commercial customers, but basically it has just kind of the counts of, you can see here, this is the number of accounts that are in this system, so the number of users that are here. You can see that each one of these things has a checksum, which lets us know if we're actually making OCR error. So you read the checksum, you read the data, and you put it all together, and you can do error correction. Here's some other metrics, right? This is that top one is the number of front-end imports, which is 11, the number of objects created by those front-end imports, which is 2048 or 2,408. The average number of objects per investigation. And you can see that you can even put sort of more complex data structures in there. So that second one is actually a JSON blob that's been jammed into a piece of paper, right? And then you can actually deserialize it off the piece of paper, which I find to be pretty cool. So this is the way that we actually get data out. Each one of our deployments, we can get these sort of reports that have everything from usage metrics to how each feature is being used, to what the overall health of the underlying database is. And you can think of this as it's a much slower period of metric reporting, but it actually lets us graph things like user adoption, what features are working in different places, which ones aren't, why users are slow to do uptake, and let us really kind of get that rich metric experience that people are used to getting with modern websites. So that's all I have in terms of prepared, but I'm happy to spend a lot of time chatting about this stuff, answering questions, going over strategies. Thank you. No questions. If you raise your hand, someone will bring you a microphone. Questions over here? Yeah.
Hey there. I'm just curious, on the roadmap, who actually prioritizes the roadmap, given that you have product navigators versus product managers, and how you navigate that?
Sure. So, good question. We don't currently actually still have product managers per se. The product navigators act as a portion of that. The rest of it is still done sort of by the separate components of the engineering team. It's a mix of things. A lot of that is set by the engineering leads who sort of also have that sort of 10,000-foot view of resourcing and what's going on, and whether or not people are getting bored. Like we've had one project that's gone on for 2 years, and it's a really important one, but some of the people are getting really kind of downtrodden where we're porting from one database to another, and we built sort of the transactional layer, and the engineers are like getting tired of having to port the product bug for bug from the old platform to the new one. Like the fun part was building the thing in the first place, and now they have to move the whole product. So there's some management of that, which I would file under cat herding, but a lot of it is really kind of a conversation between engineering and the business side to figure out what the priorities are that are going to unlock new opportunities. And I wish I had like a better recipe for it, but there isn't like a set algorithm to figure it out. It's really kind of a discussion, negotiation. Part of what goes into it is a polling of the forward deployed engineers about what they think the problem is. So there's been a huge push recently for us to engineer our way out of the amount of time people spend on site, right? So to actually lower the amount of time we have to send people out in the field to do data integration. And that's something we've been talking about for years, but we've decided that now is the time that it's actually most important. There's also, the engineering group itself is polled about what features they think are important from their perspective. And sort of each one of the groups will sort of look at what's on the slate and do like dot voting, where we kind of go up and put dots next to what we think is important. And usually, if we've done our job right of communicating context across the organization, everyone's kind of in agreement on what's supposed to happen. People have their pet projects. But usually, everyone's kind of clear on what needs to happen next.
Are you charging customers for the forward deployed engineers?
Generally speaking, the way that our model works, and we're actually experimenting with a bunch of different pricing strategies, including things like revenue sharing. But classically, the way our model has worked is that we charge you for software licenses. So for each one of those like servers that we're talking about, you pay for a server core. And it's a very different way to sell software. So you pay for a server core, but what it comes with is a guarantee that the software is going to work. So we're not charging for services. And what that's done is give us an interesting set of incentives where we want to engineer ourselves out of services as much as possible. From the customer perspective, they get the comfort that you get from buying a product. This is the same code that's running in 100 different places. It's been tested. It's not a one-off prototype to solve this problem, but it's a rock-solid, robust piece of software. But we get them away from the risk of, great, you bought the product, now it's your problem to figure out how to use it, right? So we try to make everybody happy in that regard. And it's worked out well. The difficulty we have is actually convincing people that we really do that. They're like, well, I think you're trying to charge me for services. There's got to be some kind of trap here. Maybe this isn't a product. It's like, no, really, we think this is the best way to be successful, is actually deliver outcomes to the customer.
I'm going to caveat that I'm not a technical person when I ask this question, but if you say you leave the data on the customer's database or website, you leave it there, what part of your IP is adding the meta tags and doing all that other things in it that makes it more readily available for your software to use? Are you giving up any IP or anything like that by putting it on their systems?
No. I mean, this is the way that software licensing has worked in general. I mean, what IP is Microsoft or Apple giving up by giving you, their operating system to run on your computer? Like, the answer is none, right? It's licensed to the customer. We do move data around a bit, I guess, on customer systems. So like when you deploy the Palantir stack, usually you'll buy new computers to run it on, but it'll run inside the customer network. And there it can connect up to the different databases. And the value that we provide is being able to integrate across disparate sets of data and transform it into a model that's recognizable to a human, that's not a technical person, so that when they go and they look at the interface, what they see, I like to say it has 3 different aspects. One is that it's familiar. So everything that's arrayed in front of them are things that they're familiar with. It's the way in which they already think about the problem out in the world. It could be, if you're looking at unauthorized trading, you're someone who understands trading, and you're looking at trades that traders are making. If you're doing cybersecurity, you're looking at nodes on a network. If you're doing infectious disease, you're looking at sick people checking into hospitals, right? So the vocabulary actually changes for each deployment in the same way that you change a schema for a database. But a schema for a database is still composed of data storage primitives, right? It's still about tables and rows and fields, not about people or organizations or transactions. So familiar is the first piece. The second piece is that it's interactive. So in comparison to sort of a way a lot of big data works in the world today, the interface to most big data systems is actually a data scientist, where an organization will say, tell me which one of my 5 product lines is most likely to sell in Burma, right? And the data scientists will say, okay, let me go figure that out, and 12 or 24 hours later, they'll come back with a report saying, here's the answer to that. We believe that you need to take the people who are sort of closest to the problem at hand and give them access to the data, and that the kind of answers that the world's most pressing problems require nuance and complexity and ad hoc analysis, where you ask a question and you don't know what the next question is that you need to ask. And that needs to happen in about 10 seconds. That's our baseline. Like, you ask a question, you get an answer, next question, and so on and so forth, and you work your way through complex analysis. And the last piece is actually expressivity. So it's one thing for me, like disaster relief is something that we work on a lot in philanthropic context. It's one thing for me to think through the question, show me all the medical facilities that have had their power disrupted in Tacloban, Philippines, as a result of Typhoon Haiyan, right? And that's an easy question for me to formulate in my mind, but if getting an answer to it requires me to go through 120 discrete steps of telling the computer what to do, that's very error-prone, it's very kind of clunky, it's hard to sort of to improvise around. But if I can just draw a circle and choose a type and hit a button and I see a map, that's amazing, right? And so expressivity is sort of this proxy for the efficiency of how an interface works. And we look to deliver those 3 things to the data where it lives.
Going back to your last slide, I was wondering if you could just go into further detail of what specific metrics that you guys are pulling from your customers, and an example of maybe how that's gone back to how you've altered your product.
Yeah, absolutely. Okay, so a good example, well, let's start with an overview. So it's everything from performance statistics on the data cluster itself, like how many objects are being created, how many imports are happening, things like CPU load off the individual servers, that sort of performance metrics, as it were, as well as usage metrics. So each one of the clients that the user sits down and uses, as they go into the different tools, so they might be doing geospatial analysis on a map, they might be using a timeline tool to understand how things relate to each other in time. They can use these big top-down histograms to start with billions of objects and filter their way down to an interesting set of things. Each one of those things that they do, we record and then aggregate. So we don't know exactly what they were working on, but we know how much time each user spent in each tool. And it tells us whether or not we're getting uptake in different places. So in the original Palantir software, search was kind of this pervasive thing, and there was a search bar up in the corner, and you could always go and search. And what we were finding is that people weren't using search very well. And so we created something called the Home app. And the Home app is actually just one of the frames of this application. You click on sort of a tab, and it brings up what looks like a Google search bar. Just a big search bar right in the middle of the screen. The list of data sources that you can search is underneath it. You can turn them on, turn them off. It sort of puts a really easy interface in front of search. And that was built based on user metrics that we saw that no one was using search when they should have been, right, for example. And so now when we deploy new features in the field, we ask the question, what is the 1-week adoption? What is the 10-week adoption? What is the 50% adoption, to understand whether or not we've built the right thing and how well it's working.
So I just got a question on, you're talking about faxes and everything, and I think in the Salesforce Dreamforce, not this year, the previous year, they talked about machines becoming more social and interacting more on a social level, not only being able to pull data, but actually to push stuff down to the machine in remote locations as well. Do you think we'll ever get to that? Because I know this Dreamforce, they didn't mention it at all. So.
Well, I mean, I think it's entirely possible to set up those architectures. And one of the things that we're working on this year is figuring out how to cloud deploy this for customers that are happy to do it. And they're pulling metrics off. It becomes much easier, and there's no fax machines involved. So, I think, it's always dangerous to ask a technologist, do you think we'll get there, or is it possible? Because we see the world as this empty canvas. So the answer is yes, of course. But when that'll happen, I don't know. I think we're already seeing a lot of this connectedness. If you think about all the metrics that are streaming off your phone back to the carrier, back to places like Apple, or the people who run those apps, there's a lot of data moving around already. We're sort of in that connected world, that Internet of Things, in a lot of ways that maybe we don't even realize yet. So I see no reason for that not to happen.
Oh, over here. How do you think about scaling up this business that seems to depend on pretty sophisticated professional services?
Yeah, so the answer is we engineer our way out of that, and we've kind of, if we look at, one of the metrics that we look at pretty closely is the number of forward deployed engineers per deployment, and we've seen that number going down over time, and so, the way that we move into new areas of business is often very speculative. We go into a place, we say, you have data, you have some problems, we'll figure out how to make it work. And then we might actually put 10 or 15 people on the ground, but that's actually a way for us to get product feedback in the field. So they're actually engineering prototypes based on the platform in the field. And so that part is always going to be labor intensive, but the idea there is to build an exemplar that is then repeatable across a vertical, right? So the first bank that we go into and deal with like fraud in their online bank, where people are sort of hijacking other users' accounts and then exfiltrating exfiltrating the money out of the bank. In order to do that, like we had never dealt with data quite at that scale. I mean, like the first bank we worked at was pushing out, I think, 500 gigabytes of log data a day from their web servers, and that was only part of what we were taking the data from the web servers and comparing it to transaction data inside the bank. And so forward deployed engineers there actually built a whole new way for us to store, manage, and mine data that would then feed into the interactive system. And that's now part of our product line, right? So that was sort of a kind of thing where we're kind of sometimes inventing the future in the field. So we're never going to get away entirely from putting people on the ground because that's a way for us to get really good close access to the information. But if it's a problem that we've seen before, we have a whole, like part of the engineering team is sort of split in three. There's infrastructure, platform, and UX, right? And UX is everything that the user sees. And the distinction between infrastructure and platform is infrastructure is building kind of the underlying data servers, and platform is all about how that software connects up to the rest of the world and how you manage it, how you install it, and that sort of thing. And so their mandate is to lower the maintenance burden as much as possible, from everything from data integration to day-to-day care and feeding of the systems. So we see the cloud as one way out of the professional services because then we actually have it sort of centralized and we can manage it. But even for the stuff on the ground, we just look at that as technical debt, that we try to get it down as close to zero as possible. To put it in perspective, our baseline now for a new customer where we get access to their data is 8 weeks from the word go to data up and running in a form that the analyst can use it. It was probably 3 to 4 months before that, and nowhere near the scale. So we're sort of bringing that number down and down and down. And for smaller deployments, it can be even faster. And that might just be one person instead of 5 people now spending 8 weeks doing it. Any other questions? We have 2.5 minutes left. I know it's late in the afternoon. Okay, guys, I'm going to let you out to break early. Thank you so much.